and we add the results. Although here again, these are actually not like terms, so we can't combine these. Okay. All right, that was fun. Let's look at another one. So for this one, right, again, it's distribution. So the first term here, we're going to multiply it with each term, right, with each term of the second. So we have this, okay. The first term, right, we're multiplying that with each term from the second polynomial, as you can see. And then the second term, we also multiply that with each term from the second polynomial. Again, we're multiplying each term from the first polynomial with each term in the second. With each term, oh boy, from the second polynomial. Right? Now we multiply these monomials like we saw before. So here, x to the 4 times 2x squared, right? We have 2 in front. Coefficient here is 1, so 2 times 1 is 2. X to the 4 times x squared, that's x to the 6th, right? You add the exponents. X to the 4 times x to the 5th, that's x to the 9th, and so on. 3 times 2x squared is 6x squared, and 3x to the 5th is this. Okay, that was fun. Now, I know some of you are probably thinking about FOIL, right? That's what this looks, you could solve this using FOIL, and you're right, you could do that. In fact, on the next slide, FOIL. It's just a way to remember multiplying, here, let me get that laser pointer, two binomials. Binomials means a polynomial with two terms, you know, by two, like bicycle. So with FOIL, it's just a way to remember how to multiply these two together, right? The first term, yeah, actually, let me get that. Use a different color though. Okay. Right, the first terms, that's A and C, that's first, right? A and D, the outer terms, right? On the outside, inner terms, you can see here, and the last terms. What am I doing? Okay, so that's what we get here. And this is, I think this is actually what they teach in high school, but if you haven't seen this before, that's fine. And this is just an example demonstrating it. That's all I'm doing here, right? I mean, I am showing some more steps, but really by FOIL, you get the same idea. Essentially what FOIL allows you to do, it allows you to skip this step and save some time, right? Like 3x times 2 we know is 6x. For the outer terms, you have 3x times negative x. That's where this comes from. 4 times 2, 4 and minus 4 times x. Okay. And of course, after you actually multiply the monomials, you can see there is some cancellation, mostly because we have like terms, right? We have 6x and we have minus 4x. That's why I wrote this, although I showed it on a different line probably, but that's okay, right? We have 6x minus 4x. That's where the 2x comes from, just from combining. Okay. Okay. So we have that. That's FOIL, which you might have seen it. If you haven't, that's okay. Good. So let's do some more examples. Right, so these are just some more examples I put in here. This is another one. Again, it's FOIL, but it's really just distribution. That's really what's happening here. Right, so when you multiply here, again, let me get the wonderful pen. All right, here we go, right? You have the first, multiply these two together. Okay, that's where this comes from, right? Here. oh boy, last, right? And so forth. You have minus 5x with the inner term here. Almost there. And then, oh wait, sorry, let me draw this in. Then you have last. And then, of course, just like before, you carry out the products and then, and so on. Okay, that was fun. All right, we're going. Here's some other examples. X minus 3 times x plus 3. Again, it's just another example of FOIL. But notice when you actually multiply it, in the end, I mean, there will be cancellation, but in the end, we just have x squared minus 9. Actually, let me do it over here. We have x squared minus 3 squared. Mostly because these signs are opposite, there's cancellation. So we have x squared minus 3 squared. Same thing over here, right? Well, similar, I should say. In the end, we get x squared minus 49, which is x squared minus 7 squared. This should be 7 squared. I mean, what I wrote is correct, but I didn't format it right. So it should be this. Oh, that's nice. Okay. So this is what we get here. And really what's happening is there's actually something a little bit more general happening, some kind of formula, so to say, and that's what the next slide shows. Namely, for any number b, oh wait, let me get that laser. For any number b, right, x minus b times x plus b is x squared minus b squared. That's actually what we used just before. Let me go back a bit. Right? X minus b is 3 here. X plus 3. We have x squared minus b squared. X squared minus 3 squared, which is x squared minus 9. Over here, we have x squared minus 7 squared. This formula is just a slight generalization of it. I mean, basically here we have this a is 1. So, I mean, I'm not going to ask you to, state these formulas on a quiz or exam. They really come in handy when we get to factoring. Factoring, as you'll see, is basically going the other way, the opposite way as multiplication. And these are just there's just another formula here that will come in handy, again, when we factor. It's actually based on actually one of the methods of factoring is actually based on this formula. Okay, so it's just something I wanted to show you. Let me just keep that. Yeah, keep it for now. Okay, let me just ask. Are there any? Here, let me do this. Let me do that poll thing. You love this? Oh, someone loves this topic. Awesome. I do too. Okay, so any questions? Good. Again, if you do have a question, don't be afraid to say so. I won't get upset. Good. Okay. Good. Okay, so I'm guessing that so I'm guessing everybody's good. So, okay, let's keep going then. Right here. Okay, so again, this is just another example with finding a product. Just another one I wanted to throw in there, mostly because, again, that's how you learn. It's through, what do you call it, examples. And again, it's really just distribution is what I'm doing here. So just another example. I'll just let you look at it for a bit. So again, notice also that, when you multiply, right, you add the exponents like so. You multiply the coefficients, And of course, you will have to combine like terms if necessary. I mean, we saw from the examples that that's not always going to happen, but sometimes it will. And again, these lecture notes are posted already, actually. The ones from earlier with the addition subtraction, again, that mistake I'll have to fix. So, okay, let me see. Here we go. So, see, I'm not going to get far in this because it's 12:46, but that's okay. Let me at least start it. So, the first method, as we saw here, was really distribution. The second method, it's really the same idea, but to me at least, it's more visual. Again, a student actually showed me this, a previous 104 student, I think it was my second semester here teaching at SUNY Oneonta. It's called the box method. I think some people call it the table method or the grid method. I'll demonstrate it first, as you can see, through an example. And then on the slides, as you'll see, if you downloaded them, the actual procedure is written out. So let's suppose you want to multiply these two together. As you can see what I have here, what we're going to do is we form this little grid. I guess you can call it a grid, okay? Let me get that pen. As you can see, each term from the first polynomial, right, gives us a row, whereas each term from the second polynomial gives us a column. So for each term, right, from the first polynomial, we get a row. From the second polynomial, we get a column. Notice that the negative sign I included. You don't want to forget the negative sign, okay? And what I said actually is written here as well. Okay? Even though I'm saying the second polynomial, each term gives you a column, it really doesn't matter. Namely, one of the polynomials you get rows, the other one you get columns. I said the second gives you columns, the first gives you rows. Really, it could be the other way around. Anyway, how do you get these entries in the middle here, right? Sorry, let me go back. How do you get the entries? How do you get these little box entries? What you're going to do is you're going to multiply row and column entries. So the corresponding row and column terms, if you want to call it that, that's where that goes in here, as you can see. So we have 7x times x cubed. Yeah, that's right. That's where 7x to the 4 comes in. And what's going to go over here? Well, 7x times minus 5x. And that's where minus 35x squared comes into play. Oh, great, running out of time. Here also, let me just show you the whole thing. But that's what happens. That's what happens for the table. Each of the entries here, you multiply row and column entries. And then finally, to get the product, you add up those entries together. Okay, we're out of time, actually. So I'm going to have to do a stop here. We'll continue with this on Monday. Okay, so let me stop sharing this. So again, have a nice weekend, everyone. Okay.
Thank you.
You're welcome.
Thank you.
I am around today from 2 to 3. So in case you have any questions. You're welcome. Okay. All right. See you later.